Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 13 on your homework. Alright, so the first question here says, given this system here, we have to find the acceleration of it. So what you want to do is draw a free body of the entire system. Just pretend like this is one object here. And then that object's mass would be the sum of these three. Looks like 100 kilograms. Now, there is a frictional coefficient given, so don't forget to put a frictional force in your free body. And presumably this thing is sliding, and that frictional force, remember, is equal to the coefficient of friction times the normal. When you get your free body done, it should be clear what the normal is. Then you can calculate a frictional force by 0.25 times the normal. All right, now, you'll notice I only gave one frictional force in this problem, and that's because I think this thing's fairly obviously sliding along. Well, actually, to tell you the truth, I guess I don't know. Once you calculate that frictional force, compare it to this 1,000 newtons trying to accelerate it. If the frictional force you calculated is less than 1,000 newtons, this thing's not going anywhere, and then the acceleration would be 0. I think I had intended this to be a sliding frictional coefficient. So I think you're going to end up with an accelerating system here. And then the net force acting on it is going to be this 1,000 newtons minus the frictional force. So that should get you by part A of this problem here. All right. Whoops. All right, B and C. All right, so for part C, or for the next part here where it says find the normal force between A and B. All right, sorry about the jumping video here. What you need to do then is draw a free body of either A or a free body of this part of the system. I guess I'm going to go ahead and talk about what would it look like if we draw a free body of this part of the system. So you would draw this object just like you see it. Okay. The normal between these is an internal force and doesn't go in the free body. There's a normal between these surfaces here, and it's important to know the directions. I always, picture my Ant-Man description. If Ant-Man were stuck in between these, he would be pushing to the right on B and to the left on A. So the normal force at that surface is to the right. Okay. Then you've got a gravitational force. You can either put separate gravitational forces for each object, or you can put a single weight vector down and use the total mass, would be just fine. Then you have a normal force, a vertical normal for these two surfaces. You can just put one normal up to represent the normal on those two surfaces. That's perfectly fine. All right, then you'll have a frictional force acting on this system, which is to the left in your free body. And it's going to equal 0.25 times the normal force on these surfaces only. And I'm talking about the vertical normal force. All right, once you get your free body done, then you write a Newton's second law equation and to find the normal. All right, so the last one, it says find the force that C applies to the ground. All right, so what you're going to want to do is draw a picture of C, and I'll do this maybe in a different color here. C only. And it's going to have a normal between these. You're going to have to calculate that. A frictional force to the left, you're going to have to calculate. Well, actually, that'll be 0.25 times the vertical normal on C. All right, and it'll have an mg down. All right, so let me kind of, again, re-summarize this. You draw a free body of C only, and it will have an mg down. You use this for the mass. It will have a normal up due to the ground surface. It will have a normal to the right because of these two. It will have a frictional force to the left equal to 0.25 times the vertical normal that's on this surface and this surface alone. Okay. Now, write a Newton's second law equation. Oh, actually, to tell you the truth, and that's all fine. Everything I said is just fine, but I think If I look at this question, find the force that C applies to the ground. Okay, let me go back to the free body. Hopefully you got it complete. Two of the forces that act between C and the ground is the frictional force at that surface and the normal force, which is up. So find those forces from that free body. Should be no problem. The frictional force, or the normal force, is basically just equal to the weight of the object, mg. And then the frictional force is 0.25 times the normal. Now the question specifically says between C and the ground. All right, so this frictional force is to the left on C. Think about which way would that be on the ground. And then the normal force is up on C. Think about which way that'll be on the ground. So that's kind of a long-winded description of that. I think I'll just end that right there. I hope that gets you through that problem. Have a great day.